please. Any problem that you had difficulties with that you would like to work on? Anything? Okay. 64 on 322. Very good. 322. 322. 322. 64. 64. Okay. In 64, we have f of g of h of 1. Good. And we are given, so I have to copy all these functions. So we are given f of x, which is 2x minus 5. We are given g of x, which is 4x minus 1. And we are given h of x, which is x squared plus x plus 2. Did I copy it correctly? Always keep track of that. Okay. For such a question of f of g of h of 1, I have two ways. One way would be to find this function, f of g of h, and then at the end plug in 1. Which way would be a good way, but a little bit longer. Now, if I don't want to do that, if I'm only interested in this, then I will start where? Of course. I have to start with the innermost function. This is the innermost function. Can anyone give us h of 1? Four. So this number is 4. So then I'm looking for f of h of 4. Now where is my next step? G. Of course, the innermost function. So now I have to determine g of 4. Can anyone give us g of 4? 15. Very good. So this is 15. So finally I have to find f of 15. Can anyone give us f of 15? That's it. Good pick. Anything else? Other questions for me?
Can we go over another problem from the last class?
No.
370.
Just kidding, just kidding, just kidding. Any problem.
378 on page 378.
I know that those are more involving, right? That's why I wanted to take the time and solve at least 3 or 4 of those. Once we understand and we practice 3 or 4, the rest will come easy from that point on. Yes, I'm ready. Which function is that?
So
57 on page.
Oh, on page 378.
Okay, 378. 378, 57, 57. I see it. F of x equals x squared, x minus 1 to the third, times x plus 2. So the problem here is asking us to graph the function. And we know that we have to look at 8 different pieces of information that we have to find, correct? Good. Okay. I had to delete a video from before because it uploaded. So I have enough room and I don't have to worry about the next one. Okay. Good. Perfect. Okay. So I'm asked to graph. I will get my chart going immediately. Why I'm doing this? You have at least 3 options. The first option is use the chart or invent your own. I'm fine with that. And summarize all the information in the chart so you can look at the chart and boom, 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 graph the function. Second option is you use the 14 pages in the book. Up to you. The third option is, if somebody else shows you a different method, you understand it, use it. Okay? But just copying a graph from the graphing calculator is not acceptable. Okay? Good. Domain. That's how I have to start. I have to fill up the top. Domain. Very good. Degree. 3 here, 2 here, 1 here. But when you multiply x minus 1 3 times, don't you get x cubed?
Yeah.
When you multiply x cubed by x squared, don't we get x to the 5th? And when I multiply x to the 5th by x, don't we get degree 6? Yes or no? Good. Maximum number of turns. Maximum possible. It doesn't have to turn that many times. How many? Very good. Awesome. Leading coefficient. In other words, positive. Correct. Since it's degree 6, what am I talking about? Am I talking about this end behavior? Or am I talking about this end behavior? Yes.
Oh, that was.
Yes. This one. Because it's an even degree and the positive leading coefficient. So what am I pointing to?
The temples of smiley face.
Infinity to infinity. How many solutions would you give for the x-intercepts? 6. Degree 6, 6 solutions. How do I determine that, and what do I have to write for the x-intercepts? Say it again. Awesome. F of x equals 0 to find the x-intercept. Very good. Awesome. So x squared, x plus 2. Sorry, I wrote plus by mistake, so I reversed these two. Again, how many solutions will you give? Thank you. Please dictate. How many times? Very good. How many times? How many? Very good. Awesome. Multiplicity for negative 2. Excellent. Multiplicity for 1. Awesome. Multiplicity for 0. What does this mean in terms of the graph? What does multiplicity 1 mean in terms of the graph? What would the function do at that point of intersection? It will cross. What will the function do at point 1, 0? It cross, but not the, it will cross, but not the same way. It will take its time. Okay, what will the function do at 0, 0? Awesome. I will put them in ascending order from negative 2, 0, and 1. And this is indeed the x-intercept, so then y must be 0. And I put myself in the chart, I write myself a note. One more time, what do I write for negative 2? Perfect. What do I write for 0, 0? Say it again. Careful. Multiplicity 2. Even multiplicity must be a term. And what do I write for 1, 0 again? But flat. Or whatever you want to say, but not regular. I call it cross in a flat way. Or taking its time. Or whatever you want to invent. I'm fine. Okay, so ready to follow my hand? Please. Positive infinity. It crosses at negative 2, 0. But obviously it has to turn. How do I know? Because it has to come back to the origin and turn. Right? So it has to turn again. Because now it crosses at 1, 0 and goes to infinity. One more time. Positive infinity. Crosses at negative 2, 0. It has to come to a turn. How do I know? Because now it's coming to 0, 0 and turns again. and it turns. But it has to come to another turn because it crosses again at 1, 0 and goes to infinity. Ready? So, we plot the points we have first. The points we have are -2, 0, 0, 0, and 1, 0. And as you see, I don't care about anything anymore other than my chart. All the information is summarized there. So, from positive infinity, regular cross. It has to come to a turn because it comes back and turns again at 0, 0. And it's turning, but it has to turn again because it crosses flat. Oh, crosses flat. See? So crossing flat is this. See the difference between this cross and this cross? So this is our function, f of x equals x squared, x minus 1 cubed, and x plus 2. And yes, I don't have any knowledge of how low this is. And I can't with algebra. I can with calculus, but not with algebra. And I don't know how low that goes. But we'll figure it out in a minute. Very easily. In y equals, clear, whatever you have. And it was x squared. In parentheses, x minus 1 cubed. And then x plus 2 in parentheses. Okay, now I have to think about the viewing window. I graphed the function. I know how it looks like. But I have to identify the viewing window. I don't care about the positive side that much. So positive 1 or positive 2 is good enough. But I should see the negative side more. So in the window, the action happens between -2 and 1. So I'm going to say -4, 4. With a scale of 1. I can always go back and adjust. Why minimum? I don't know. For now I'm going to say -20. I have no idea. Why maximum? Not more than 2. There is nothing, no action about the x-axis. And with a scale of 2. Let's see what happens. And hit graph. Okay. So it's coming from positive infinity as I expected, crossing a -2, 0, coming to a turn again. Calculator is lying here. Unacceptable. A lie. This is a lie, right? So the graph does not continue on the x-axis. There is no such thing. We already know that that's not going to happen, right? Because there are only 3 different x-intercepts, not infinitely many of x-intercepts, right? So we're going to investigate that in a moment. And it crosses again at 1, 0 and goes to infinity. That's why I didn't care about the top. I know it's infinity. There is nothing happening there. I need to determine this, and then I will investigate between 0 and 1. So let's determine the minimum with second and calc. You want to use my calculator? So you have to put in the y equals. Okay, so we want the minimum, so I'm going to choose 3. I see the minimum is somewhere between -2 and 0. -2, enter, 0, enter, no guess. Just give me the minimum. So the minimum I will put in my chart, -1.6. And the minimum value is -18. Now, I no longer care about this side, but I care about what happens here. Because I know that that's not correct. Don't trust the calculator. Trust your understanding. So I go back to the viewing window. And this time I only want to see between 0 and 2. and with a scale of 1, but y minimum, -2 to 1, with a scale of 0.5. Let's see what it's giving us. Ah. See, it's not crossing fast, it crosses slow. I don't like the viewing window. I'm going to go back to and make the y minimum -0.8. I see there is a minimum. It turns at 0. Maybe I should show -2, so we see how it turns. So here it is. It's turning at 0. It's coming to a minimum. And look at this cross. See this cross? Let me change that too. I'm going to change it to -3. See this cross at -2, straight. Look at this cross here at 1. It's not like this one. It's very slow. It takes its time. So now I can find the minimum between 0 and 1. Second in calc, minimum is 3. 0, enter, 1, enter, give me the minimum. And the minimum is 0.42, -0.08. 0.42, -0.08. Now I know absolutely everything about this function. I put those ordered pairs here. This is the absolute minimum and the local minimum. This is another local minimum. Is this better? Good. Other questions? Other questions? Anything else you'd like to go back to? Say it again. Yes. So let's choose another. You trust me to choose one, or you want to choose? You can. No. I'd rather you choose. Because I can. I'm dying to ban you from choosing. Let's see what. Just kidding. Just kidding. Which one?
55.
55. Okay. And we have in 55 -3, so this is f of x, -3, in parentheses x minus 1 squared, and in parentheses x squared minus 4. Notice that I didn't mention anything about symmetry because there is no way with a straight cross here and a slow cross here function to be symmetric. Okay, so that was item number 8. Okay, so what do I do now? Yes, very good. Let's start with a degree. Awesome. What is the degree of this polynomial? How much? It is 4. Do you all agree with 4? Okay. How many terms can this function have? Maximum. So degree 4 terms. This is not correct. Maximum possible number of terms. But you know what I mean, correct? Good. Is this okay so far? Good. So domain, please. We shouldn't be thinking about the polynomial. Yes, the polynomial function has domain all real numbers. Good. Since the degree is even, what am I looking for? Number 1, number 2, number 3, or number 4? Number 4. Why? The leading coefficient is negative. Number 4 means what as the end behavior? Very good. Awesome. Negative, infinity, everything false. Okay, good. Now, how many solutions will you give? 4. I'm ready. X equals? How many times? What is the multiplicity then? Very good. And then what do I do with x squared minus 4? X squared minus 4? Yes? You either move 4 and take the square root and you give me 2 solutions, or you factor. Very good. Awesome. So what is the multiplicity for 2?
1.
What is the multiplicity for negative 2? Good. So then in ascending order, I have negative 2. 0 has to be in the chart. 1 and 2. What will you tell me to write above negative 2? Very good. What will you tell me to write above 1? Very good. Multiplicity 2 must be a term. What would you tell me to write above 2? Very good. Now I need the y-intercept. 0 minus 1. Negative 1 squared. 1. 0 minus 4. Negative 4 times negative 3. Careful. So let's do it again. I plug in 0. 0 minus 1. Negative 1 squared. 0 minus 4. Negative 4 times negative 3. We only talk about multiplicities for the x-intercepts. Don't ever think in terms of the y-intercept. That's it. That's just one point. Very good. Ready? Let's analyze this. From negative infinity, crossing at negative 2, 0, crossing at 0, 12, it has to turn because it's coming at 1, 0 and turns. It has to turn again because it's coming at 2, 0 and going to negative infinity. One more time. From negative infinity, crossing at negative 2, 0, crossing at 0, 12, I don't know how, but it has to get to the y-axis. It has to turn somewhere because it's coming back at 1, 0 to turn, but then it has to turn again because it comes back to 2, 0 to cross and go to negative infinity. Does it make sense? Should I do it again? Is it clear? Okay, very good. All I need is the chart. Don't care for anything else. We start with the points we have, and they are negative 2, 0, 0, 12. I'm going to say that this is 0, 12. 1, 0, and 2, 0. Also remember one thing. A polynomial function has to be a smooth graph. Meaning, when I graph something like this, it has to be very smooth. Not twisting my wrist. It's very smooth. If I have to twist my wrist to get it to a point, something is not right. So, it's coming from, I'll explain in a minute what I mean by that. It's coming from negative infinity. From negative infinity to this point, crossing. Then somehow it has to cross the y-axis. I don't know if it does this. It's unlikely that it does this. And I don't think it does this. Because it's kind of difficult to do this and then come back here. It's more likely that it's this. You understand my point? So this will be more difficult. How do I get here and turn and come back here and turn again? This is kind of vertical. It's unlikely. Can it do this? Possible. Unlikely. I don't know. You just pick the function. I haven't never looked at it. So I think it's going to do this, but we can adjust the graph immediately after that. No problem. This is what I think is the case. So from negative infinity, crossing at negative 2, 0, somehow crossing the y-axis at 0, 12, coming back at a turn. This must be a turn. It has to come up. It's a turn. It has to come up to another turn because it's crossing freely, straightforward at 2. This is what I think it is, negative 3, x minus 1 squared, x squared minus 4. Let's put the function in, because I need to determine this, and I need to determine this. This is a local min, but it's very clear. It's on the x-axis. The other one is not. The other two. So in y equals, clear if you have anything. So we put in negative 3, in parentheses, x minus 1 squared, and in parentheses, x squared minus 4. I have to decide upon the viewing window. I don't want the calculator to dictate me. I decided the viewing window because I have the graph. Definitely, I don't care for the negative part now. There is no action, nothing happening under the x-axis. So how high do I go? Definitely above 12, right? So I will say for the x-axis between negative 4 and 4, it's good enough. But for the y-axis between negative 1 and maybe 30, I don't know. So window, negative 4, 4, with a scale of 1. For the y minimum, negative 2 is good enough. But y maximum definitely past 12. I'm going to put 50 with a scale of 5. See what happens. I can always go back and adjust. Well, pretty good. As I expected, it would have been very difficult to do this. I would have twisted my wrist to graph that. It has to be smooth, continuous function. So negative 2 from negative infinity to a maximum, crossing at 0, 12, coming to a turn at 1, has to have a maximum, and crossing freely at 2, comma 0. So I have to determine this and I have to determine this. But you understand that without doing the work by hand, without analyzing the graph, I would have not been able to come up with the viewing window. I would have punched in numbers like 3 or 4 times, but once I had the graph, I had a feel for it. Okay, so let's determine the maximum. So second calc, it's maximum number 4, and it's between negative 2 and 0. So negative 2, enter 0, enter no guess. So it's at negative 1.2 and 37. That's it. That is also the absolute maximum. And now I want to determine this maximum between 1 and 2. Second calc, still a maximum, but this time between 1 and 2, and enter. And it's 1.7, 1.6. 1.7, 1.6. I know absolutely everything about this function. No secrets whatsoever. Any questions for me? Any questions for me?
Yeah, like why?
Yes?
I understand like in this problem, we're talking 0 to get 12, and on the first problem we've done.
Well, because we already had the origin. We obtained it as an x-intercept. I cannot, a function, if it's a function, cannot have 2 x-intercepts. A function cannot do this. If I already found that when x is 0, y is 0, I'm done with the y-intercept. If it does this, it's not a function. So a function has to have 1 y-intercept. Very good point. Very good question. Yes, anything else? Kathy?
This is a mechanical question. How do I get it from X into X max? Because no matter what I do, it just goes to
Well,
0.
second and quit. And now you start again. Second and count. Second and quit. Get out of that viewing window with second and quit.
Okay.
If you don't like what you see, second and quit. Anything else? Other questions for me? Okay, the next section, 3.3, is a complete review from a previous class, but I'm going to go over it. So 3.3, division of polynomials. This is preparation for what follows in the last section of this chapter. So this is where we are. Oh, there is no problem 443. I don't know. As I said, I don't know. It's a typo there. I didn't work on this. I'm working on the calculus problem. So just don't worry about that problem. Okay. Ready? So there are two different situations here. A polynomial divided by a monomial, and a polynomial divided by a polynomial which has two different possibilities. If I have a polynomial divided by x minus a, I'll explain when we get to it in a minute, I can use synthetic division or long division. Both work for such a situation. If I have a polynomial divided by a polynomial, not x minus a, then only long division works. So we will be looking at two situations. One, in which I divide any polynomial you can think of by one term. One term, one monomial. And the second situation when I divide a polynomial by a polynomial, but I have two options. The long division always works. But if I have something like this, I have the option of using the synthetic division or the long division. Okay, so let's start with the first type. And I'm choosing problem. There is none in your book, but I have to present it. I disagree. Okay, so I'm going to give an example from the first one. Let's say x cubed plus 2x plus 1 divided by x squared. Is this a polynomial at the top? Is it in descending order? Is this just one term in the denominator, one monomial, one term? Okay, the only possibility here is to split the fraction. Into how many fractions? Exactly, because the numerator has how many terms? That's it. So x cubed over x squared plus 2x over x squared plus 1 over x squared. This is a case that even if I just show one example, I still have to show it. Can move on. I simplify x cubed by x squared. X, indeed. Very good. Plus. I simplify 1x from the top with 1x from the bottom. And I get 2 over x. And plus 1 over x squared. Even if you say, what kind of division is this? I will still have to say this is the only way. It may not be what you expect, but that's the only way when I have a polynomial divided by one term. I am allowed to split the fraction. At no other point I'm allowed to split the fraction. If I have, don't correct anything, don't change anything. If I have here plus 1, I cannot split the fraction. Only when I have one term in the denominator. Okay, so now we are going to talk about the long division. And then we'll take problems that work with synthetic division. I think I'm on page 4. Okay, Now I can choose from your book. Okay. Let's say problem 6 on page 392. 6x cubed plus 17x squared plus 27x and plus 20. Everything divided by 3x plus 4. Question. Divide using long division. State the quotient and the remainder clearly. Before we do this, we have to talk about the following. Let's say I want to divide 10 by 3. What do I write as the answer? So 10 divided by 3 is 3 integers plus a remainder of 1. 1 divided by 3. And you could say, but wait a minute, with numbers you can write this as 3 integers and 1/3. Yes, I will cross it out because it's correct, but I will cross it out because when I write the answer for division of two polynomials, I have to have a symbol. I cannot write it as if I have numbers. Exactly. It has to be like this. Or minus if the remainder is negative. Yes. Second thing that I would like to make sure you understand, I know we don't do this by hand anymore, but let's say you are in the desert and you have to divide and you don't have a calculator. So you have to divide, let's say, 3722 by 15. Bear with me, because I'm making a point that I would like you to understand. My first question to myself is 15 goes into 37 how many times? And I'll say 2. Then I go back and I distribute or multiply 2 times 15, and that's 30. But it's positive 30. I have to change the sign because I have to subtract. Although 2 times 15 is not negative 30, I must change the sign. Perform the operations I see. This goes away, and I have 7. I bring down the next in line, 2. Now I'm asking myself, 15 goes into 72, so it's 30, 60, so it's 4, right? Okay, 4. I go back with 4, and I distribute 4 to 15, and I have 60, but I have to write negative 60, although 4 times 15 is positive 60, I must change the sign every time I write underneath. And then I continue with 12, and I bring 12 in, and so on and so forth. This is exactly the same thing we're going to do with this, but of course it will look very sophisticated and way more difficult. Why? Because it has x in it. Okay, so now next question for you is, are both in descending order? They are. Perfect. Is there a missing term from the top?
Yeah, whatever x is.
No. What is the degree of this polynomial? Degree 3 is there? No, it's not 6. We're not adding degrees. So the highest, that's why quadratic is degree 2, not degree 3 or 4, right? So the leading coefficient and the leading term will give us. So the degree is 3. Is degree 3 there? Is degree 2 there? Is degree 1 there? Is degree 0 there? Perfect. So there are no missing terms. What if there is a missing term? I have to leave some room in there, empty. But there is no missing term. So I start this algorithm exactly the same. So I have 6x cubed plus 17x squared plus 27x and plus 20. And I'm divided by 3x plus 4. First question. 3x multiplied by what is 6x cubed? Awesome. Now careful what I do next. Remember I used the word distribute, which I didn't need to in the number. I need to distribute 2x squared to both terms. Change the sign from whatever to the opposite sign and write below like terms. So 2x squared times 3x. I have to write negative 6x cubed. For the same reason I wrote here negative 30 and I wrote here negative 60.
Question.
2x squared times 4, yes.
Can you rewind back a little bit?
Say it again.
So can you rewind back?
2x squared times 3x is
No.
6.
How did you get it 2x squared?
I'm asking myself 3x multiplied by what is 6x cubed. So I need a 2 and an x squared. Better? 2x squared times 4. Negative 8x squared, and I have to write on the like term. These two go away. I perform the operations I see. What am I left with? 9x squared. I bring down the next in line. My next question is now 3x times what is 9x squared? If this is degree 2, the next one has to be 1 lower. And the next one has to be 1 lower. And the next one has to be 1 lower. So don't forget that. Good. So 3x times what is 3x squared? 9x squared. I need sign.
Negative.
Never. We never change the sign at the top. We only change the sign when we write underneath. It was a trap.
Yes.
Good. So then what do I write? Very good. 3x times 3x is 9x squared. Subtract. 3x times 4. Now I change the sign to negative 12x. This is gone. 27 minus 12. Bring down 20. 3 times what is 3x times what is 15x? Sign, please. Awesome. So 5 times 3x is 15x, but I change the sign now. And 5 times 4 is 20, and I change the sign now. It happens that there is a remainder of 0. So then, what do we say when I divide a polynomial by another polynomial and the remainder is 0? What can I say about this polynomial? What does this
It's divisible.
polynomial represent for that polynomial? Say it again. Awesome. 3x plus 4 must be a factor of the numerator if there is no remainder. Is that clear? Okay, so let's write the answer. The answer is 2x squared plus 3x plus 5. And I'm going to write no remainder. Remainder equals 0 means that 3x plus 4 is a factor of 6x cubed plus 17x squared plus 27x plus 20. Yes, it must be a factor. Very good. Any questions?
So we have to write all that out in the event that there's no remainder.
No, but I want you to remember it. This is crucial. Very important. Okay. Let's talk about the synthetic division. This was the long division, yes. This was the long division. This is the algorithm for the long division. Let's look at the synthetic division. Let's pick problem 18 on page 392, or you can pick. We're going to do at least 2 here. Now, I'm going to ask you, can I use this synthetic division here? Remember the requirement for the synthetic division. Any polynomial you can think of, but the denominator has to be x minus a. It could be x plus 5. It could be x minus 3. It can be x minus 1. but it has to have a leading coefficient of 1 and a degree of 1. Anything else? Synthetic division doesn't work. Here's the algorithm for synthetic division. In this little box, I have to identify A. That's where A goes. So if you compare x minus 1 to x minus A, you will say A must be. If you compare x minus 1 to x minus A, 1. Is there a missing term from the top? No. What is the degree of the top? And what is the degree of the bottom? 1. When I divide anything that has degree 2 by anything that has degree 1, what will the answer? What is the degree of the answer?
1.
Very good. Good. All coefficients have to be at the top. Leading coefficient 1. The next in line 1. The next in line negative 2. In synthetic division, I have no choice but copy the first coefficient at all times. Next step, 1 times 1. And I write the answer here. I perform the operations I see. What do I get? 1 times 2. The answer. The last one is boxed in always. So then what is the answer of the division x squared plus x minus 2 over x minus 1? What degree did we decide that the answer has to have? Good. So I want an answer that has degree 1. Indeed. Exactly. X plus 2. Since the remainder is 0, what can you say about x minus 1 for x squared plus x minus 2? Is a factor of x squared plus x minus 2. Okay, let's choose another. Let's say 25. Yes.
The very first one we did?
Yes.
With the 1 term?
Yes.
That's not.
It has no name.
Oh, okay.
I don't have a name for it, but this is the only way when the denominator is 1 term. I cannot use this and I cannot use this.
Okay.
The only way is to split the fraction and simplify each fraction by itself. Okay, ready? I don't remember what I said. 22. Okay, 5x cubed minus 6x squared plus 3x and plus 11. And we are dividing it by, I'm going to change it to x plus 2. So this is no longer 22. Because I wanted to choose one with a positive in there. So we can discuss that.